Good evening, chemistry students. Today we're going to learn how to do some half-life problems. But before we can start there, we need to know what half-life is. As it says on your screen, it's simply the amount of time it takes for a radioactive sample to decay so that only 1/2 of its initial mass is left over. Now, if you talk to some other students from other schools or perhaps who have taken honors chemistry, you'll find that there is an equation where you can just plug in some numbers into your calculator and you will chug out the correct answer. But that's not my goal here. I would like you to understand the concept of half-life. What happens to the mass of a sample as time goes by, and what is a half-life exactly? And I think that solving these problems using a data table is the best way for you to reach that goal. So again, it's not just about getting the right answer. It's also about understanding how half-life actually works. So let's begin. So I'm going to do a couple of examples for you. And here we have example number 1, where the half-life of zinc 71 is 2.4 minutes. If one had 100 grams at the beginning, how many grams would be left after 7.2 minutes has elapsed? Okay, so before we start doing this, I like to call this a little grocery list, which is an inventory of the information that we're given in the problem. So in this problem, we are given the following. First of all, the half-life is 2.4 minutes. The next piece of information that we're given is the initial mass, and I'm going to notate that with little m and a subscript of an I. Oh no, go away. There we go. And according to the problem, I have 100 grams at the beginning. Well, beginning is just another word for initial. So we're starting out with 100 grams of material. The final mass is what we're looking for. So M sub F is our question mark. But we're also given 2 times. So the half-life is 2.4 minutes, which I have over here. But then we're also given how many grams would be left after 7.2 minutes has elapsed. After 7.2 minutes has elapsed. So 7.2 minutes is our final time. So T sub F is 7.2 minutes. There's one other time that I want you to write down in your inventory, and that is the initial time. So T0, or I'm sorry, TI, initial time, is 0 minutes. Because at the beginning, no time has gone by. So our time then is 0. So here we've got our inventory. Next, what I'm going to ask you to do is to create a data table. And for every half-life problem that we're going to do in this class, the data table is the same. So at the very top, we have the number of half-lives. And I'm going to abbreviate half-lives with capital H, capital L. In the middle column, I put time. And in this case, we're using minutes. So I'll put that in parentheses. And in my final column, I write the amount. Actually, let's change that to mass. And in this case, we're using grams. So here's our data table, and the data table is going to be the same again, no matter what kind of half-life problem you're doing. The next step is to start filling in our columns. Always, 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 in the number of half-lives column and in the time column, the very first numbers that you put in are 0. If you forget to put the zeros in, then the rest of your rows are going to be messed up. So make sure that you put those in. So at time 0, we have to write our initial mass. Well, if we come back to our inventory, our initial mass was 100 grams. And I don't need to put the G here in the table because I already have it up here in the heading for this column. Okay, so we are going to do some simple calculations until we reach 7.2 minutes. So after one half-life, 2.4 minutes has gone by. How do I know? Because my inventory says that one half-life is 2.4 minutes. After 2.4 minutes, my initial mass is going to decrease by 1/2. So I'm going to take that initial mass and divide it by 2 so that I get 50. What I'm looking for as far as my time column is I'm looking for the number 7.2. Since my time has not reached 7.2 minutes yet, I need to create another row. After 2 half-lives, 2 time increments of 2.4 have gone by. So I'm going to add the half-life here, which is 2.4. And what I get as far as minutes that have gone by is 4.8. After 4.8 minutes, my mass of 50 grams is halved, and I get 25 grams. Has my time reached the final time of 7.2 minutes? No, it has not. So I need to create another row. After 3 half-lives, I have to add another half-life. So I'm going to add plus 2.4. And when I get that, now I'm at 7.2. That is my final time. So whatever the mass is in the right-hand column, that's how many grams would be left after 7.2 minutes has elapsed. Well, again, I'm going to divide my mass by 2, and 25 divided by 2 is 12.5. And I'm done. At 7.2 minutes, I have 12.5 grams of a sample left. So I'm going to circle that final number and put my units there. And now I am done. But there are lots of other different kinds of half-life problems that you can do. Let's look at one more example. Here we are. After 24 days, 2 milligrams of an original 128 milligram sample remain. What is the half-life of the sample? Well, I'm going to start by writing out my inventory. So my first piece of information is after 24 days. That means that that's the final time. So my TF is 24 days. And then it says that 2 milligrams of an original 128 milligram sample remain. Well, there's 2 pieces of information there. My initial mass is 128 milligrams, and my final mass is 2 milligrams. We are looking for the half-life of the sample. So half-life is, we don't know. And also remember that your initial time is always 0. All right, it looks like I've got my problem inventoried. Let's create our data table. So once again, in the upper left, we have number of half-lives. In the center, we have time, which in this case is days. and we have mass, and my units of mass is milligram. Always, always, always start off by putting zeros in half-life and time, and then you put down your initial mass, which in this case is 128 milligrams. All right, after one half-life, we are not sure how much time goes by because we don't know what the duration of the half-life actually is. So we can put nothing in this middle column yet. But what we can do is divide our mass by 2 to get 64 milligrams. So I'm going to continue to follow this pattern until my mass reaches 2 milligrams. And then I'll show you what we do next. So after 2 half-lives, we get 32. After 3 half-lives, we get 16. After 4 half-lives, we have 8. Notice that I'm just dividing by 2 every single time. After 5 half-lives, I have 4. And after 6 half-lives, I have 2. All right, we've finally reached our final amount, 2 milligrams. And now what we have to do is figure out what is the half-life of the sample. Well, in order to do that, I'm going to count how many times we have to add the half-life to get to 24 days. Because according to our problem, that was our final time. So we would have to add the half-life 1, 2, 3, 4, 5, 6. So that means that some number added to itself 6 times gives me 24. Another way to express that is with an algebraic equation. 6 times some number equals 24. How do we solve for x? We have to divide both sides by 6, and x is 4, which in this case is 4 days. That is the half-life of the sample. So let's see if it's correct. So after one half-life, 4 days goes by and we have 64 milligrams. After 2 half-lives, we add 4 to my initial 4 and I get 8. And after 8 days, we have 32 grams. Well, 8 plus 4 is 12, and after 12 days, we have 16 milligrams. 12 plus 4 is 16, and we have 8 milligrams. 16 plus 4 is 20 to give us 4, and is 20 plus 4 24? It sure is, which means that we are correct. Our half-life is 4 days. All right, so since this is an actively learn activity, this is a problem that I'm going to ask you to consider and answer some questions on. Thanks for listening. Have a great night.